In this question, we're asked if the proposed Lewis structure is reasonable, and one way we might consider this is the octet rule. But first, we need to make sure that there's the right number of valence electrons. So in this case, we have OF2. So this is an oxygen and 2 fluorines, which should have 6, because oxygen is in group 6A, plus 6 plus 2 times 7, or 20 electrons. So this should have a total of 20 electrons. Here we have 2, 4, 6, 8, 10, 12, 14, 16 electrons. So this can't possibly be the correct Lewis structure. So no, it has the wrong number of electrons, and the correct number is 20. In this case, we have HCN, which is 1 plus 4 plus 5, which equals 10 total number of electrons. If we look here, there's 2, 4, 6, 8, 10. So the first step to writing a Lewis structure is counting the number of valence electrons, and we have 10 electrons, and we've placed 10 electrons. Now we have to see if the elements that want to have an octet have an octet. So there's 2 electrons in each of these dashes, or each of these covalent bonds. Hydrogen doesn't want to have an octet because it's a small element, so it wants to have 2 electrons, like helium. But carbon and nitrogen do want to have octets. This carbon has 2, 4, 6, 8 electrons around it. This nitrogen has 2, 4, 6, 8 electrons around it. So this seems like a reasonable Lewis structure. If it were me, I would go one step further and calculate the formal charges. If we look at carbon, it wants to have 4 valence electrons because it's in group 4A. There are 2 electrons in each of these bonds. We consider here 1 belongs to hydrogen and 1 belongs to carbon, and for this bond 1 belongs to carbon and 1 belongs to nitrogen. So essentially each bond has 1 electron belonging to carbon. So carbon wants to have 4 electrons around it, 4 valence electrons, and it has 1, 2, 3, 4. It's neutral. Nitrogen wants to have 5 electrons around it. Well, here these lone pair electrons each belong to nitrogen. So it has 1, 2, plus 3, 4, 5. Nitrogen wants to have 5 electrons. It has 5 electrons. So this has a formal charge of 0. So for lots of reasons, this is a good Lewis structure. Here, we have a similar Lewis structure to above. It's still hydrogen cyanide. However, it's a little bit different of a configuration. So here we still have 1 plus 4 plus 5, which equals 10 electrons, because it's the same hydrogen, carbon, and nitrogen as above. But here, if we look at the octet rule, carbon has an octet, and nitrogen only has 2, 4, 6 electrons around it, so there is no octet. And the particular problem is nitrogen not having an octet. If we were to go a step further, which the question doesn't ask us to do, we would find the formal charges aren't very good either. If we look at nitrogen, it wants to have 5 electrons around it, but it only has 1, 2, 3, 4. So it is plus, okay, because it is missing an electron. And carbon wants to have 4 electrons around it, and it has 1, 2, 3, 4, 5. So it is minus because it has an extra electron around it. These formal charges are not good. Note that we could easily fix this Lewis structure for them by moving these lone pairs over here. And when you do that, you'll get H bond C, triple bond N, and the lone pair remains on nitrogen. Now all the formal charges are 0, everything has its octet, and it's a good Lewis structure. Note it's also the Lewis structure that we just saw was good from above.